are just me showing you how to use the unit circle. So first 4, you can see the trig function is already isolated. So I'm just going to show you how to use the interval at the top of the set of problems, and then how to find theta using your unit circle. And then after 4, we'll start to actually solve the equations. Okay, so first thing is for 1 and 2, right? We're solving the equation for theta being between 0 inclusive, because there's an equal to part. So theta, the angle measure, can equal 0, up to, but not including 360. And I'll explain why it doesn't include 360 when we get to one of those. But for now, we know we're in degrees, so we want a degree answer, right, instead of radians, which will be down here. And our answer has to be between 0 and 360. So this is already solved for us. Sine of theta is alone. And we know that the sine is always the y coordinate. So we want to look at our unit circle, and we want to find the spots where the angle measures where the y coordinate is negative root 3 over 2. Okay, so start at 0, and you want to go around the circle and just look at the second coordinate. And you want to find the 2 angle measures where the y is negative root 3 over 2. Okay, and that's going to be how you solve.
300 and 240.
Good. Okay, if you look at 300 and 240, both of those have a y coordinate of negative root 3 over 2. So those would be our 2 solutions. Okay, again, this is how we solve for theta once we've isolated the trig function. So these are just to show you how to use that unit circle. Okay, so go ahead and for number 2, again, we're still y because it's sine. Find the degree measures where the y coordinate is negative 1/2. And it's a really good habit to get in to always start at 0 and open up counterclockwise. I know sometimes you can jump to a spot, but later on our constraints will change. And you really want to get in the habit of not just letting your eyes go everywhere. Just always try to circle around. It's a good habit to read it in. Okay, what's one of them?
210.
3, what is it? 3?
210.
210, thank you. And the other one?
330.
330, good. And if you ever need to check to see if your degree measure made sense, remember you can just plug it in here, right? Is 300 between 0 and 360? Yes. Right, is 240 between 0 and 360? You'll see when the constraints change that if you plug it in there and it doesn't work, then that's not going to be a solution. All right, so now let's just repeat it here for number 3, but the constraints have changed only in that now we're given our answer in radians. Okay, it's still one full rotation around, but it gives us the pi in there, so instead of giving a degree measure, give that radian measure that's right next to it. Okay, we're just going to do number 3 here. I don't think we need to do both. Okay, so we know that cosine is always x, so go ahead and find the 2 radian measures where the cosine is negative root 2 over 2. What's one of them?
225.
What's right next to it in radians?
5 pi over 4.
Good. And what's the other one? 3 pi over 4. Good. Okay. So again, that's going to be our last step every time. We're actually going to have to solve the equations using inverse operations, but I just want to make sure we could use the unit circle correctly first. All right, so let's start. All right, so number 5. I always check my constraints, right, my interval, and it's for a couple reasons, because they're going to get smaller later, but from here I know it's 0 up to 360. And 360 tells me it's in degrees. Okay, so a full rotation around, I'm going to look at my answer in, and it has to be in degrees. So looking at number 5, negative 2 is our constant. We got to add 2 to cancel it out. so I get sine of theta equals 1. Okay, with the quadrantal ones, like 1 when it's not like root 3 over 2 or 2 over 2 or 1/2, sometimes you're only going to have one answer, sometimes 2, sometimes none. So if we go and we look for a y coordinate of 1, there's only one spot where that's going to be true. That's the top of the unit circle, right? So that's at 90 degrees. There's nowhere else, if you picture going around the unit circle, right, there's nowhere else where that y coordinate could possibly be 1 because that's the highest point on it. So this one only has one answer. All right, number 6. To solve, we've got to divide by 2. All right, that 2 is attached to the sine of theta by multiplication. So let's divide it out. So I get the sine of theta equals what? 0, right? Remember, 0 divided by anything is 0. So now we're looking for a y coordinate of 0. And we got to be careful, make sure it fits in our constraints. So again, it's a good idea to always start at 0 degrees. And you can see there at 0 degrees, the y coordinate is 0. So 0 degrees is our first answer. And we go around the unit circle. The second time that y coordinate is 0 is over at 180. Now I cannot then keep going around and use 360. Okay, that's why 0 is included, but 360 is not. 0 is the first angle you come across that has a y coordinate of 0. You can't use that same coordinate again. Okay, so if 0 is included, 360 is not going to be, because that's right back to the same point again. Okay, so that's why you have to be careful here. The 0 is included, the 360 is not. So that's all we got for answers. All right, try number 7, and then I'll show you how to do one of the fractional ones. Make sure that you really see what it's attached by. That -8 is attached by multiplication. I see people try to add 8 all the time, but it's not a constant. It's a coefficient. It's attached. So divide out -8. And that's going to give me positive 1/2, right? Negative divided by negative is always a positive. So x coordinates between 0 and 360 of 1/2. We got 60 degrees and 300 degrees. All right, so the way I'm going to show you today to get rid of the denominator is just multiplying through by it. So we just have to make sure if we find a denominator, if there's just one denominator, we're going to multiply through by whatever that denominator is. If there's more than one, you always take the bigger of the 2 to multiply through by. But here we only have 1. So I'm going to multiply every single term by 2. Now I see some people like do this to show they're going to multiply everything, but then they don't. They just multiply the first term. So the way I like to show it is literally showing that every single term is going to get 2. So that one's going to get multiplied by 2. That one's going to get multiplied by 2. And this whole thing is going to get multiplied by 2. So that's going to give me -10. And then most importantly here, plus 2 cosine theta. Make sure that trig function gets a 2. And in the right, we've chose to multiply by something that's being divided. So I don't have to go in there and distribute. The 2 divides out with the 2. Okay. So I'm just left with -10 plus root 2 on the right. And find your trig function right here. So 2-step equation. I've got to cancel out the constant first by adding 10 to both sides. final step before we find our solutions, we gotta isolate by dividing that 2 out of there. Now, as you're giving your answers, make sure to check your constraints. You don't want to get points off after solving it correctly by not giving the angle measure in the right form. So we're in radians again. So I'm looking for an x coordinate of root 2 over 2, but my answer has to be with the one with the pi in it. Right? So we've got pi over 4 and 7 pi over 4. All right, to number 9 for me real quick. Make sure your answer fits in the constraints. And then we're just gonna do a few more. You want to divide by -4 to get 1. There's only one spot in the unit circle within that rotation, right, where the x coordinate is 1, and that's at 0 radians. Okay, remember we can't count the 2 pi radians because the first one you start at is 0 radians. You can't double use that point, so, right, it says it right here. It has to be less than 2 pi. It can equal 0, but less than 2 pi. And we show it's radians by not putting the degree mark. All right, so now we're gonna hop around a little bit. All right, so I'm gonna show you how to do 11. 11 is important because when you multiply through by a denominator, you have to make sure that you're multiplying every term. Okay, terms are separated by additions or subtractions. So how many terms do I have here on number 11? And you have to be careful.
2.
On the right side, I have 2. Excellent. Right? I have a -4, and I have a 1/3 times the sine of theta. Those are attached by multiplication, so it's 1 term. Okay, so when I multiply through by 3, I'm going to multiply the whole fraction on the left by 3. Right? I know that'll cancel out the 3. And then I have to multiply the -4 by 3, and the 1/3 sine of theta by 3. Okay, this software just always shows that dot, but it's the same thing as if it was like this. All right, 1/3 sine of theta. So multiplying through by 3, those 3's divide out to 1 on the left. And then that's going to equal -12 plus 3's divide out. So 1 sine of theta, which is just sine of theta. And then it's just a quick one-step equation because sine of theta only has a constant next to it, so let's add 12. So I'm going to get that the sine of theta equals -√2. Okay, there's nowhere in my unit circle you're going to find a root 2. Okay, now if I were asking you to find the sine or the cosecant or secant of something, that does bring you to a -√2. But we're not going to do that. We're just going to do sine, cosine, tangent. So if you get something that's not in the unit circle, no solution. Okay, there's no solution on that unit circle that works for that y coordinate. All right, so try 13. And then on the last slide, I'm just going to show you 2 where we have a limited interval. So 13, and then we'll skip to the back page. Be careful here because there's 2 denominators. Okay, multiplying through by 2 will not cancel out a 4. So you always have to pick the bigger of the 2 to multiply through by. So you're multiplying through by 4. So this is what you should have when you multiply through by 4. And 4 times 1/2, or half of 4. Either way you want to see it, it's just kind of simplified down to 2. And then remember, you never have to distribute. You're picking a number that you know is going to cancel out with that denominator. Just 4 divided by 4 is 1. So quick 2-step equation here. I'm going to subtract 12. So negative 2 sine of theta is negative root 3. And then be careful here just because you're dividing out a negative to make sure that right side you may simplify into a positive. So divide by negative 2. So sine of theta equals root 3 over 2. Okay, so find y coordinates of root 3 over 2. Keep your constraint in mind, it has to be in radians. So you should get pi over 3 and 2 pi over 3? Wait, that's not right. Yes, it is. Yes. All right. So the last couple that we're going to do are when the constraints are limited. So if you look up here, we're just going to do one of those. We're going to do 16. If you look up here, it's now from 0 to 180. Both are included because they don't require to double use any points. But this is why you always want to read it from 0. Because 0 to 180, you start at 0 and go to 180, it's only the top half of the unit circle. So anything not in the top half, you disregard. And if there's none, you would just say no solution. All right, so solve this out. We're going to divide by negative 8 to get the cosine 1. And then we want an x coordinate, where I want a theta, all right, degree measure, where the x coordinate is 1/2. And 60 is going to be the only angle measure that works here. Okay, because the other one is down on the bottom at 300 degrees, and that does not fit our constraint. That's why it's a good idea, like say you did this just by looking and you forgot. Go back and plug them into your constraint. Is 60 between 0 and 80? It is, so you likely got that one right. But is-
Interruption. Cross country team, please go to the gym.
Is 300 between 0 and 80? It's not, right? Your theta has to fit in between those two limits. So then you would be like, oh no, this one isn't working. But... All right, so now let's do 18. Now let's take a look at our constraint. Now we're going from pi to 2 pi. Okay, so going around the unit circle counterclockwise, which is how you always have to go, pi to 2 pi is the bottom half of the unit circle. So only answers in the bottom half will work. And we have to give them in radians. So I gotta divide out -6. And then you can see that I have things I can simplify on the outside of the radical here. All right, that's going to simplify to 1/2, which is just going to be √3/2. So if you look for a y coordinate that's positive in the bottom half of the unit circle, you're not going to find it. Right? Y is only positive in the top half of the unit circle because you're going up. So that's another situation where you could have a no solution. Okay, you could either get a number that doesn't make sense because it's not in the unit circle, or you could get values that don't fit in your interval. Okay, so that's that.